Hello everyone, I am Geethika. I am from CSC. My roll number is 522. I am currently pursuing my BTech in VVIT. Today I want to discuss about monitor solution. Let us see the topics we are going to discuss in this session. What is a monitor and why monitor solution is used? General structure of a monitor. Operations on condition variables. Producer consumer problem using monitor solution. Let us discuss these topics in this session. Let us see first, what is a monitor? As earlier we know that semaphore is an integer variable. Like that, monitor is an abstract data type. Next, why monitor solution is used? We have four type of solutions to solve critical section problem. First, what is a critical section problem, right? No two processes can enter into critical section at the same time or at the same particular time. So to solve the critical section problem, we have four types of solution and the monitor solution is one of the solution. The monitor is one of the ways to achieve process synchronization. The monitor is supported by programming languages to achieve mutual execution between two processes or two or more processes. For example, Java is synchronized methods. Java uses synchronized methods. Like we have seen wait, signal, notify, like these methods. It is the collection of condition variables and procedures combined together in a special kind of module or a package. The processes running outside the monitor can't access the internal variable of the monitor, but can call the procedures related to that monitor. Only one process at a time can execute code inside monitors. Let us see general structure of the monitor. Here you go. Similar to class in Java, we have the structure of the monitor as monitor, name of the monitor, and declaration of shared variables, and then declaration of condition variables. And then we declare some procedures as of our requirement. At the last turn, initialization code. In here, the initialization code means nothing like a constructor. In Java, we use constructors, right? Here also the same thing. This initialization code is used for initializing the shared variables or condition variables. Next. Let us see the purposes of all these structured members, means procedures, shared variables, condition variables, initialization code. In a monitor, 0 or more shared variables are declared using syntax rules of Java language. Similarly, 0 or more condition variables are declared with the following syntax condition list of variables. Here the syntax goes as condition and condition variables. Means we will declare as condition first and then we will write what are the condition variables we want to declare. 0 or more procedures are defined. The procedures do not return any value. The shared variables in the monitor can accessed by only the procedures of the monitor. Here, we declare some shared variables, means the common elements, common variables which are shared by the both processes or all the processes. So we cannot access the shared variables directly here. So we use the procedures to access those shared variables. The procedures of the monitor can access and perform operations on the shared variables of the monitor. The initialization code is like a constructor in Java, as I said earlier before, and is used for initializing the shared variables of the monitor. Condition variables are used to implement mutual exclusion or solve critical section problem. A queue is associated with each condition variable. Let us see. Here, we have said the condition variables, right? These condition variables perform two operations. Every condition variables must and should perform two operations. The operations are wait and signal. When any process calls wait operation on any condition variable, then the execution of that process will be stopped and the process will be placed into the queue associated with it. When any process calls signal operation, then any conditional variable, then a waiting process from the queue of the condition variable will be restored. Means it restarts again. At a particular time, only one process can call a procedure of the monitor. Currently, if a process is invoking a procedure, if any other process tries to call the same procedure, then other process has to wait. With the above property of monitor, the mutual exclusion is implemented automatically in the monitor. Here, let us see producer consumer problem. as an example for monitor solution. In a producer and consumer, the producer always tries to produce items and consumer always tries to consume the items. Here you go. As per general structure, monitor PC. PC means I consider as producer and consumer. Here the shared variables are n, buffer, in, out, count, x. And the shared conditioned variables are full and empty. I take two conditions. First, the first procedure is insert. Insert means when this is the procedure related to producer, means producer always produces items, right? Means it has to put some values. So in that we have given some parameter list. If count equal to when, means whenever the buffer is full, it has to wait. It cannot produce items. Next, as per the code, buffer of in equal to x means we are putting the item into the buffer. Next, we'll incrementing the in value, means we are incrementing the index positions. Next, count. We are incrementing number of items in the buffer. Signal of empty. Here, if the buffer is empty, means it will give a signal to the producer. It is empty. We have to produce the items now. Now let us see. Next procedure means delete. Delete is related to the consumer process. Whenever a consumer consumes item, it automatically one item will be deleted from the queue. So if count equal to 0, empty, weight of empty. Here weight of empty means whenever there is no item in the buffer, then consumer process should wait until producer produces some item. Next, here also we'll remove the item into the x variable and we are incrementing the out, means index positions, and then count. We are decrementing count here. If one item is removed from the buffer, then number of items will be decreased. Signal of full. Whenever producer produces all and the buffer is full, the consumer will easily consumes from the buffer. Here, initialization. As I consider n equal to 5, means number of items must be 5. In starts from 1, out also starts from 1, count 0. Initially, the number of items in the buffer will be 0. Let us see producer process and consumer process. After writing this monitor, we have to write producer and consumer process. Here, producer is while true. We can produce number of times, like print and enter item means we are trying to insert item. So we'll write scanf and insert of item. We'll write the item into the insert processor. We'll call as pc.insert, means it belongs to the monitor PC. Same. Similarly, consumer process also perform some procedure operations, right? Here we will write pc.delete, means we are calling delete procedure from the monitor. Like this, whenever one process is in the critical section, no other process can enter into the critical section. Like this, we can assume mutual exclusion from monitor solution. Thank you.